Okay, let's take a look. So I think I marked one of the worksheet, but I haven't had time to mark all of them. This first one. Okay, most of them are correct. Exercise 10A. Good. Oh yes. Do you need me to review with you the basic rules? Basic. What do you call
I
it?
think it's okay.
Properties. You can check your textbook at the front page. They list down everything for you very nicely. Right? Yeah. Okay. Then which is the one that was wrong? Had some errors. Let me see. Yes, this one, question 4. Okay, so question 4, you assume that angle CED is 90 degrees, right? You assume it's 90 degrees, but you actually don't need to assume that to solve this question. It may not be 90 degrees. Can you get what I'm saying?
Oh.
Okay, let me show you. This is question 4, right? Okay, let me just. Okay, I have to add a new page. I'll annotate it below. Yeah, so for question 4, how did the diagram look again? You start off with a circle. Oh, right. And then you have a line. And what else? You got a diameter. Give me a second to draw this out. Tangent line. Okay, and then another line that cuts across like this. What are the name of the points? A, O, B, E, D, and C. Right? Can see whatever I'm drawing. Right? Okay, good. So what was the assumption you made? You made the assumption that angle CED equals to 90 degrees, but actually this is not required. Okay, this is not required. Let me show you a different way to do this without assuming CED is 90 degrees. Okay? Ken?
Yeah.
Question 4, part 1. This one. Okay, so let's go. In this case, we got this diagram, right? Question 4, part 1 requests for us to do what? It requested for us to show the angle ABC equals to angle ECD. Now, you made the assumption that which angle was 90 degrees again? CEB, is it? You said that this is 90, right? Don't need. Is it CB? Let me just confirm again. CED. Oh, the other one, sorry. Yeah, you don't need to assume it's 90 degrees. This is 90 degrees. You don't need to assume that. Let me show you how to do it. So okay, let's begin. So what I would do, right, is I will just label angle A as the angle that we want. So in this case, we want to find angle ABC and ECD, right? So ABC and ECD. I'll label angle ECD as angle A. Okay. Angles ECD equals to A. Then from there, I can continue my proof. So let's see. We can also extend this EC all the way, right? In a straight direction, so that it lands at a point X. Let's call this X, okay? Then for convenience only, then angle ECD is equal to angle ACX. Can you agree with that? This one and that one, same, right? So therefore we write that down. Angle ACX equals to angle ECD, which is then equals to angle A. Step by step, this is because vertically opposite angles. And by why is it equals to angle A is because of definition. Okay, so let's label on the diagram. So we end up with an angle A over here. Good. So what else do we know? We also know that this angle ACX. Okay, maybe it's better if I present it this way. Angle ECD, I'll start off with that, is equals to angle ACX, which is originally equals to A. Okay, but then this angle ACX here, it's actually equals to angle ABC. Do you know the reason why? ABC.
ABC.
What is this line?
It
Is that
straight line.
no, yes, but a special kind of straight line.
Tangent.
Tangent. You got tangent, and then inside you have a triangle. They're meeting at one point. More specifically, there is this line here that separates the circle into two pieces. Major segment, minor segment. So this angle here and that angle there. Why are they equal? What's the reason?
Angles in opposite segment.
Not opposite, but the correct phrase is
Alternate.
alternate. Yes. So this is alternate segment theorem. Okay, so this is the first question where you get to use alternate segment theorem, I guess. Okay, then that's good. So what? So that means that we can we know that angle ABC is equal to A, huh? Then we are done already. Isn't that what we required to do? We are requested to do. ABC equals angle ECD. Okay, then we're done. Actually, you don't even need the A, huh? Don't even need the A. But I like to label the A to make it more mechanical. Don't have to think so hard. Okay, so it's also, then we're done already. Proven. 2 lines only. Okay, now moving on to part 2. Okay, moving on to part 2. Now for part 2, this one a bit more long-winded. What was the request? They want you to show that BE and ED are equal. BE and ED. So this guy and that guy are equal. Let me show you how I did it. Yeah. This one and this one equal. We know that BE is equals to EC, right?
Maybe, you know that B, okay, cause both tangent and like.
Yeah, the name is called tangents from external point. Okay, tangents from external point. Yeah. What else do we know? If once we know these two are equal, this will become a.
This becomes isosceles.
Isosceles. Maybe I just don't put the double tick here because let's pretend that we didn't know these two are equal first.
Okay.
Okay. I'll just highlight it instead. So they are not equal yet, but we're trying to prove it. But we have proven so far that BE and EC are equal. So this is an isosceles triangle. Very good. So what do you know about isosceles triangles? Base angles are the
same.
Same.
It's 90
okay, so,
minus A.
Pause. Here, I'm trying to show you a different way instead of assuming that it's 90 degrees. How do you know that this is 90? Have you proven it already? Tangents from external point, circle, tangent, the ice cream cone. Is it guaranteed that this angle here is always 90 degrees? All we know is that this is our tangent, this is our tangent. How do we know this is 90? We don't. You need to prove it. Okay? So we can avoid, but what I'm trying to tell you here is that you can actually avoid trying to prove it. Here is how you would do it. This guy, do you agree that it's a radius? OB?
Yeah.
Okay, so maybe I'll just write it down at the side. This one I guess is obvious. I never really wrote it down in my working. OB is radius, fine. Then this OBD is also a tangent, right?
Yeah.
So what can you conclude about the angle OB? Radius, tangent, what's this angle here?
90.
Exactly. So this angle OBE, is it OBE? Is that what I'm going for? Let me just check first. Yeah, OBE must be 90 degrees. Tangents perpendicular to radius. That's good. Then what is angle CBE then?
Angle CBE is 90 degrees minus A.
90 degrees minus A. Okay, this one I'll just draw a huge square like that to remind you it's a 90. Then angle CBE must be 90 minus A. So far, have I assumed that this angle is 90 degrees?
No.
No, okay, good. This one is just adjacent angles because they are side by side. You don't need this reason, to be honest, it's quite obvious. Adjacent angles, or just the short form. CBE, okay. Then BCE is 90 minus A. Yes, because base angles of isosceles triangle. Okay, can I just write it down? B, C, E. I need the diagram. If I zoom out like this, is it okay? I
Yeah.
hope you can still see. Maybe to be a bit more precise, it should be equals to CBE because base angles of isosceles triangle, they are the same. And then it's 90 minus A. Okay, good. So we now know that, okay, I'll just remove this 90. I have another 90 degrees minus A. Okay, good. So what else do I know? What is angle CED then? This guy.
90 minus A plus 90 minus A.
This one, there's a rule for it that I think I didn't introduce
External.
this. Yeah, exterior angle, not external. Exterior angle
Oh.
equals to sum of interior opposite. Okay, so angle, let me write this down. CED is equals to angle CBE plus BCE. This is exterior angle equals to sum of the interior opposite angles. This is interior. Basically like this. If you have a angle A here, angle A here, angle B here, the outside here will be A plus B. Do you believe me?
Yeah.
This one, the reasoning is if you start off with A, B, and C, what do you know about the sum of these three angles? Must add up to 180, right? Okay, good. But then if you let's say pretend you didn't know this and you call this X, then you're trying to solve for X. But what else do you know about C and X? They are both sitting on a straight line. So what is C plus X? They are both sitting on a straight line. So therefore, adjacent angles on a straight line are
The same.
they add up to
180.
180. Okay, good. So both are equal to 180. So you can just equate them together, right? So as a result, you get what? C plus X equals to A plus B plus C. Cancel the C away. What are you left with? X equals to A plus B. You have proven the theorem. Exterior angle equals sum of interior opposite. Okay, X is the exterior angle. Then exterior, so adjacent, just beside it is the interior. So this C is the interior angle. And interior opposite means you look at C, you point to the two directions. Opposite of C is angle A or angle B. So it doesn't matter which is which. You just take the sum. Exterior, interior, opposite. Sum of the interior opposite. These two will give you the exterior. Okay? It's a shortcut. Right? Okay, good. So therefore, we end up with 90 degrees minus A, 90 degrees minus A, which is 180 degrees minus 2A. Is that okay? Let me just label on the diagram. CED is now this angle, 180 degrees minus 2A. Okay, good. So what else do we know about this triangle here? We don't know that it's isosceles. Yeah, we're trying to show that. We're trying to sort of indirectly show that it's isosceles. So if we know two angles inside a triangle, can we find out the third angle?
Yeah, sum of angles in a triangle.
Did I have to use the fact that this is an isosceles triangle?
No.
No, I did not. I'm using 180 minus these two. So that means that this triangle, if this I didn't draw it, so if this was like a bit more slanted like this, then it's not really isosceles, but it still works. Okay, I'll just draw it properly. Okay, but it is an isosceles triangle, and that's what we have just shown. After you calculate this last angle, so let's just call this X, I guess, just for convenience. That's CDE. So X equals what?
A.
Exactly, correct. And then as a result, you have shown that the two base angles are the same. Therefore, triangle CED is
iso.
Okay, let me just write it down first properly. So I don't call it X, I'll just call it CD. Okay, so now since angle CED equals to angle CDE equals to A by okay, I'll just bracket base angles. This implies that triangle CED is isosceles triangle. And since they are isosceles, it is an isosceles triangle, this implies that which two lengths are equal? Triangle CED is isosceles, so which two lengths are equal?
A and X.
No, I'm not asking about the angle. I'm asking about the length.
CE and ED.
CE equals to ED. But what
So
else do we know about CE?
B equals to CE, therefore BE equals to ED.
Correct. Apple equals to orange, orange equal to pear, therefore apple equals to pear. Apple equals to orange equals to pear, something like that, huh? Like, this is called the transitivity property. Very obvious, okay? Like, BE equal to EC, so CE, which is the same as EC, is equal to ED, and then we are done. That's how you prove it. Therefore, okay, I'll call this number 1, I'll call this number 2. Then I'll write down by 1 and 2, this implies that BE must be equals to ED. Okay? I did not have to assume that this guy here is a 90 degrees. That one, I also don't know if it's 90 degrees or not. But actually, now you can prove that it's 90 degrees. You can you see why?
Proof is 90.
I think so. Wait, is it not? Let me see. Or can I just leave that as an exercise to you?
Wait, which one?
This angle here, angle BEC.
Oh, yeah, it's
Right.
90.
Yeah, it's 90. Like because if this is 90 minus A, this is 90 minus A, this angle here must be 180 minus. So it must be 90. Is it right? No, it's two-way, it's two-way. It's two-way, not 90. But since this is a isosceles triangle, right? We know that this guy is already A, right? So actually, do we know for sure it's 90?
Yeah.
Why?
It look like it.
It looks like it. Okay, I guess for most.
These are not parallel, is it? Or
you mean BEC and OB, is it?
yeah, it doesn't say that.
Yeah, they didn't say that, but you can probably prove it. Once you've proven it, then you would have shown that it's 50. Let me think.
I mean,
would it not
okay,
be parallel?
This is 90. Then like this has to. Oh wait, no, because it's not parallel. I was gonna say interior angle.
Yeah, the C shape, right? You probably need a proof by contradiction. But we this is the end of the question already. That's all. Shall I move on?
Yeah.
You can go think about it. Should it be a 90?
Yeah, it's 90.
Yeah,
It's
obviously.
definitely
Yes, correct. Okay. Just a point about question 5. This part, yeah, your reasoning is fine now. But I just wrote it a different way. You can go take a look. You can just say by whatever, then they are parallel. Don't need to say so long. Yeah. Question 6 is okay. And then, sorry, I haven't had time to look at the other questions. Let me look at it now. Okay. See. Okay, let's look at question 7. I need to bring up the question first. Hold on a second. Question 7. Okay, in the figure, you have an angle ADC, it's 90 degrees. AE is the diameter of the circle. By joining B and E, prove that the angle CAD equals to BAE. Okay, I have to draw the diagram. Let me just draw it. A, D, C, E, B, join B to E, right? You want to show the angle CAD equals to BAE, is it? CAD is here, BAE is where? BAE is here. I'll show that they are equal. Let me see your working. ABE is 90 degrees. Yeah, correct, because AE is a diameter. ACE is 90 degrees, correct, because it's a diameter. Then angle CAD, you let it be X. Okay, you call this X, can. Then angle ACD, where is it? It's over here. You would say 180 minus 90 minus CAD, which is angle sum of triangle, okay? Then substitute this with X. 180 minus 90 is 90, okay? Angle BCE, where is it? It's over here. Is angle ACE, the big one, minus away ACD, the small one, okay? Which is 90 minus 90 minus X. This one calculated from before, okay? Expand it, you get X. Good. So angle BCE is a X. Correct. Then angle BAE is equal to angle BCE because of angles in same segment. Very good, yeah. And it's equal to X because we already shown that BCE is X. Angle BCE is X. So therefore BAE is a X, CAD is also X. So we have proven it. Yeah, okay, good. Can. This equals to this equals to this. Okay. Next, question 8. In the figure, you have a PQ as a diameter of the circle. Okay, let me try and do this, mark this without drawing the diagram. PQ is a diameter of the circle. S is a point on the circumference. A and B are points on PQ such that angle SBQ equals to 90 degrees. AS bisects angle PSB. Have I done this question before? Did we go through it in class?
I don't know.
I think I did. Yeah. I definitely went through it. That was the last question last week.
Oh, long.
Right? Is it not? Okay. Let me just double confirm. Let me scroll up and see. Yeah, I went through it already. Okay, then I don't go through. No. Moving on. You can go and check the video. Okay, question 9. Don't waste your time. Question 9. Let's take a look. In the figure, you have A, B, C, and D are points on the circle. Given that CD equals to CB, prove that the AC bisects angle BAD. Okay, bisect, do you know what it means?
Make into like two, like
split.
How to say, like if like if this bisects, then this will be 90, this will be 90.
Correct.
Like
yes. But not restricted to 180 degrees divided.
If this is bisect, then this will be like 30 and 30.
Okay, you got the idea. Yes, correct. Just divide by 2. Split into 2 equal halves. Right? Okay, let's just look at your working. So angle CDB equals to CBD. Yes. Hold on. Right, because they told you CD equals to CB. Oh, that was a given fact. Correct. Base angles of isosceles triangle. Yes. Then CBD equals to CAD, angles in same segment. Okay, then angle CAB equals to angle CDB. Angles in same segment again. In. Yes. So what? So that means that we have a CAD equals to CAB. Hold on a second. CDB and CAB. Right. Okay. This one, the working can be improved a little bit because it was not so clear immediately. Like the CDB was linking to here, right? From the first working, then link to CBD. So just like a trigo proof, try to meet in the middle, you know what I mean? Like present it this way. CAB equals CDB, then equals to CBD. Then you get stuck here, then you move from the back. Angle CAD equals to what is it? Angle CAD equals to angle CAB. Wait, actually, what am I doing? Let me see again. CAD, yeah, actually, sorry, just one line only. What am I doing? Here to here. Present it like this, so that it's a bit clearer. Then CAB go to CDB. This is because of the reason you gave, angles in same segment. Then CDB equals to CBD. What is this reason? CDB equals to CBD, base angles of isosceles. Angles of isosceles. And then finally equals to angle CAD is because again in angles because of angles in same segment. And then you're done, right? Don't need to move around. A bit clearer. Okay, then question 10. Not done, is it?
Don't know. I mean, I think I tried, but I can't do it.
Okay, can. Let me just go through then. Let's go. Question 10. I need to copy down the diagram first. Give me a second. Okay, huge circle first. Another huge circle, but even bigger. Wow. Okay, and what else we want? A to D. Okay, wait a minute. Let me just adjust the diagram. Overlap maybe a bit more than half, like this. Okay, can. A, D, oh. A, D, and what else we want? A whole bunch of lines. Let's just draw in. Okay, I need a different color. Let me just get the right color first. Okay, no, up to here only. What else we want? We want this diagonal, but extend a little bit more. What else you want? Extend to this guy, but you extend all the way here. What else we want? Here, extend to there, extend a bit more, and then connect these two lines. This one pop out too much, just adjust it a bit like this. Okay, then I will disguise the inaccuracy by drawing a fat dot like this. Okay, can, good. Let me just label the points first. Okay, can. So in the figure, you have A, B, C, D, and A, P, R, D. They are two circles intersecting at point A and D. ARC and BPD, they are straight lines. Okay, ARC, let me just highlight it up. This one and that one are straight lines, the yellow and blue highlight. DR is produced. Produce means you extend. You extend either left or right until it meets BC. So extend towards this direction. So DRS is a straight line as well. I'll just highlight it again. Green, another color green. Then you want to prove that PR is parallel to BC. PR parallel to BC. So what are the three rules you can use for proving parallel lines? Maybe I'll just draw an arrow first. The three letters you must remember.
3 letters.
I'll just tell you, Z, F, and C. What do they stand for?
Alternate angle.
Correct.
Corresponding angle. Interior angle.
Exactly. Good. What's so special about interior that differentiates it from the other two?
This one add up to 180.
A and B is not equal, but instead A plus B adds up to 180. Exactly. But if it's here and here, there and there, the angles are equal. Okay, good. Okay, so that's how you prove it. You have to show you either have a Z, or F, or a C in order to show that they are parallel lines. I think you can either have a F shape here, right? Can you see the F like this? Can you see the F?
Yeah.
Or another F is here, like this. Another one is a C shape like this. Can you see a C shape?
Yeah.
Or another one is like this. So a few different ways you can prove it. Z shape, a bit difficult. Huh? Z shape requires you to be like, oh, we actually have one Z. There's only one Z here. So you can show this angle equal that angle. Okay. But those are the only possibilities. Like either the, sorry?
They don't even give you like,
Say again?
they don't even give you like anything like.
Yeah, they didn't give you anything. They ask you to prove parallel lines. You must know straight away you need to show either one of those shapes, the F, the Z, the C. You need to show those two angles are equal. So let me just look at my answer key first. If not, I waste your time. Let's take a look. I start off with an angle DPR, and let me just double confirm first. Hold on. Right. Okay, can. Okay. Yes, correct. Okay. And let me just confirm first before I talk. Right. Okay. You'll be surprised by how short the proof is. Okay. So first off, since I have an iPad, I can copy and paste. I can do this. Let me just make 2 copies of the same diagram. And let me start off like this. I erase all the irrelevant. Oh, actually, that was relevant. Okay. Let me filter out. You see what I'm doing. I just erase a few lines, right? But now, if I just continue erasing a bunch more lines, so that we focus on really what is relevant here. Can you see that these two angles are equal? Let me just change the color. Wait, what color can I use? Let me see. I'll use pink. This angle and this angle they are equal, right?
Angles in same segment.
Very good. Okay, so let's just record that down in the diagram. This one, no, this one equals to that one. Okay, can? Maybe I'll put double to make it more.
This one equals to this one.
Which one? Sorry. Yeah, I moved.
This one. Wait. This one equal this one.
True, but not very relevant. I focus on the small circle just now already. What do you think I want to focus on next?
Big.
On the big circle. So let me just erase the small circle.
No. Wait.
You want Z, F, or C, right?
What is this?
One more step only. You must learn to filter out the irrelevant information.
This equal to this. Okay.
Shall I review?
Oh, this. I mean, this.
Yes, you need the angle. Equal to what? You need it to be equal to
this.
DP, right? So ignore the, can you erase away your DPR? DPR only. No. Keep the DBC. Yeah, I give one instruction, you do one thing. Yes, keep. Now look at those two angles.
Oh, angles in the same segment.
Exactly. They are equal. Let me just erase all the irrelevant information. Is it more obvious now? These two are equal. Right, then you're done already. So it's only 2 steps. Okay, So this question, actually you must realize that in math, if a lot of information is given to you in a question, it's a good thing. It means that you don't need to do a lot of working because everything is there already. You just need to filter out what's relevant, what's not relevant. Okay. So let me just write it up nicely. It's really just what you want. Our goal is, let me just highlight this F shape. Can you see the F shape? Okay, I'll just write it up. Yeah, you already get how to solve it already. Our goal is to show that this pink angle and that pink angle, these two here and here, are equal. So in other words, angle DPR is equals to angle DAR because of angles in same segment. Sorry, I'm writing in short form. I hope you understand. Segment.
Yeah.
Then angle DAR is in turn the same as angle DAC. If you want to really be precise, this is because ARC is a straight line. So DAR and DAC are the same thing. So once you have angle DAC, if you look at the filtered second circle, you realize that it's really just equals to angle DBC because of angles in same segment in the second circle. Okay, and then you're done. This one, okay, sorry, one more line. By what's this corresponding angles? The two lines are parallel. Wow, the lines PR and let me just follow the question. PR parallel to BC. Yes, PR parallel BC. Okay, that's all. Okay, next question. Yeah. Well, most of the time was spent on drawing the diagram. Okay, let's go on. Question 11. Okay, another huge circle. Give me a second to draw this out. Okay, big one and a small one. Intersect somewhere like this. Where is the center? A bit to the left. Okay, something like this. Okay, center is here on the circumference. Then I'll just label in a different color. What do I want? I want a point Q extend all the way here. A PS, and then it extends all the way to point R. And then a point T, a point Q. What else do you have? S joined to T. S joined to O. Wow. Try and make it straight so it looks nice and less confusing. S joined to Q, O joined to Q. And then finally R joined to Q. Is that all? Did I miss anything?
No.
No? Okay, can. So let me read the question. In the figure, O is the center of the smaller circle QRST, and that PSR and PTQ are straight lines. Part 1, prove that PQ equals to PR. Okay, yes, good. Okay.
I don't know how that helps. I don't think it helps.
Yeah.
I saw. I mean, okay. SO. These are both radius, so I saw.
Correct. Yeah.
Both are 180 minus 2x.
Okay.
I don't know how that's useful. Okay, then wait, no. I don't know how that's useful. Wait, what? I want to prove this is this, right?
PQ equals PR, correct. Maybe I'll label it like this. Does it help? I don't know.
So this should be X. Yeah, this should be X.
Correct, if it's an isosceles triangle. Yeah. So our goal is to show that this large angle is X. This yellow one is X. How?
Okay. Okay, this is a cyclic. Wait, no, this is what you call.
Yes. Cyclic quadrilaterals. Which one?
But I thought it's like this one.
Yes, correct. A cyclic quadrilateral. As long as you are 4 points on the circumference.
Okay. Isn't this like 180 minus x?
You're required to wait. Why? Why is it 180 minus x?
Wait, no, never mind. Okay.
The yellow angle, you don't know that it's x yet. You're trying to prove. That one, the opposite one, right? It's 180 minus x, correct?
That one is 180 minus x.
Correct. Write that down. Then what's the angle just beside it? Okay, I'll write it down for you. This one is 180 minus x. Of course. Then the other one must be x. Okay.
So this must be parallel.
Which?
But how do I prove that?
Good point.
Okay, wait. Is this the major minor stuff?
Let me see.
No.
No, you don't need that. No. At least not in my proof. There are many ways to prove the same question. Many different ways to do it.
Okay. And T is not the center, right?
No. But you identified cyclic quadrilateral just now, right? Can you see that there are let me see. There are 3 cyclic quadrilaterals. Can you see the 3 different cyclic quadrilaterals? Oh, sorry, 2 only. Sorry. Sorry, 2 cyclic quadrilaterals. You highlighted one already. That's in the smaller circle. How about the big circle?
Here.
All circumferences, right? Can we just erase the irrelevant information?
This is 180 minus 2x.
Yes, correct. Okay, good.
And then, how does that even?
What shape is this?
180 minus 180 minus 2x minus x equals x. Therefore, base of isotriangle.
The conclusion, just copy the question.
Equal what? PR.
Yeah. Nice.
Okay.
No alternate segment theorem. Okay, let's just write it out nicely. So what is the relevant information? Let me see. Yeah, so far you actually didn't need this one yet. Right? The 180 minus 2x. I think later we need. Yeah, but you need the x and 2x. So maybe we can start off with let angle PR, no, not PRQ. Okay, PRQ. PRQ equal to x. So this implies that angle SOQ equals to 2x. Is it okay if I don't write the reason, I just read it out verbally, then you fill in on your own? Okay, this one is angle at center equals to 2 times angle at circumference. Okay, this one here, 2x. So now we know SOQ equals to 2x, then we have to think and then realize that, what is it? PSOQ is a cyclic quadrilateral of the big one. You don't have to write this down, of the big circle. So this implies that angle, what is it? RPQ. Okay, technically I should say SPQ because that's the angle that is inside this cyclic quadrilateral, right? SPQ. But then I am changing it, instead of SPQ, I change it to RPQ. Why am I saying that? Because I want to link it to the triangle later. I hope it's not too confusing. This one, is, the reason is angles in opposite segment of a cyclic quadrilateral, right? 2x opposite of 180 minus 2x. They add up to 180. So to go from 2x to the other guy, you take 180 minus 2x. Okay, very good. So now you zoom out and you see that in triangle PRQ. Okay, sometimes when you're very confused already, you should just write down in triangle PRQ to remind yourself, which shape am I looking at? Oh, triangle PRQ. Which shape am I looking at? Cyclic quadrilateral PSOQ. Okay, I don't know if it helps you. In triangle PRQ, what do we see? We see that you can also redraw the triangle. I see that there's 180 degrees minus 2x at the side here. I see that there's an x there, and then there's an unknown angle that I want to find, which is the angle PQR. 180 minus x minus 180 degrees minus 2x. There is no need for me to put the pair of brackets around this x here because it's only a single term. So let me just erase that. You put also not wrong. It's not wrong to put it. Distribute the minus, you get minus 180 plus 2x. 180 cancel away, minus x plus 2x is just x. So angle PQR is equal to x. So therefore, we can update this question mark with an x. Now that we have x here and x there, we know that by, what is it? Base angles of isosceles triangle being equal. We conclude that, what is it? Sorry, that's not the correct presentation. I should say that angle equals to that angle, which is PRQ equals to PQR. It implies that triangle, which is, what triangle is this? PRQ. Is isosceles triangle, which implies that, what was the conclusion we needed? PR equals to PQ. Okay. This one is a sum of angles in a triangle are supplementary, or angle sum of triangle. I always found this phrasing a bit weird. Angle sum. Like, what's angle sum? Sum of angles in a triangle are supplementary. Okay, but you get the idea. Let's move on. This is part 1. Let's move on to part 2. Wow, this question not done. Oh, okay. Is it? That's part 2, right? Given that PS equals to PT. So now they tell us PS equal to PT. So let me just label it like this. Single line here and a single line here. So I hope you're not confused between PI equals to PQ, which we have proven just now, versus PS equal to PT. Different idea now. They give us the short one equals to the short one. Show that PS is parallel to QR. So again, when you see parallel, what do you need to think of? The 3 letters?
Interior, alternate angle, and corresponding angle.
The Z, F, and T shape. So here, let's see. Okay, you already shown that this is a X, right? This is what shape here? PST? When you know PS equal S, PS equal PT? Isosceles triangle. So can you find the base angle?
Yeah.
What is it?
180 minus 180 plus 2x, then divide by 2.
Yeah, correct. Which is? Okay, I write it down. Okay, angle PTS equals
X. It's just X.
Correct,
X.
yes. The reason is angles, sum of angles in a triangle are supplementary. This one then divide by 2, right? Everything. So it's just X. Do I need to show the working? I'll just show it. Okay, minus 180 plus 2x and divide by 2. 180 minus 180 cancel away. 2x divided by 2 is single x. Okay, so I'll label that x and x. Okay, these two are equal because of base angles of isosceles triangle, which is also equals to angle PST. Okay, good. Then we can conclude already. You see angle x here, you see angle x here. What rule is this? To conclude ST parallel to RQ. TS, QR, same thing. Which rule? What shape do you see?
Corresponding angle.
Corresponding angles. Okay, so we say that angle PST equals to angle PRQ equals to X. This implies that by what is it? What is it again? Corresponding angles. This by corresponding angles, sorry, that implies should be afterwards. Yeah, by corresponding angles, this implies that we have our conclusion TS parallel to QR. Okay, this part should be black. Okay, Ken, then let's move on. Question 12. Okay. Circle. Let me see diameter. Oh, okay. Diameter. Got a radius here. Got a parallel line. Then we have AQ like this. Okay, let me label the points. Parallel, parallel. Okay, O is the center of the figure, PQ is a diameter, AB is a chord, which is parallel to PQ. AQ and OB, they intersect at point X. Prove that angle BXQ here, maybe I should use a different color. I use black. Here, BXQ, sorry, is equals to 3 times of angle PQA here. So 3 times, maybe I'll just put a triple line like this. Just for fun, to indicate that it's triple, right? PQA is the smaller angle, then BXQ is the bigger angle, 3 times as big. So that's why I put a triple line. How?
How? So what do you want to find?
Show that this is triple of that.
Okay. Okay, that's not useful. Parallel. Okay, this is that alternate angle.
Okay, yes. So maybe we call it X. So we're gonna show this is 3X. Question mark.
Okay, and then
what about this angle? This angle here. Can you conclude it's the same as X? Angles in same segment?
oh yeah.
No, cannot.
Wait.
Why cannot?
Why cannot?
Angles in same segment. What's the condition? Start at the same 2 points on the circumference. This starting from the center, it's not a point on the circumference. Can you see? They're different. This angle will only be the same as this angle, this angle, this angle, this angle, this angle, or this angle, or this angle. Okay, actually the bottom one is
but here is X.
Why? Why?
Okay, I take that back. I take that.
I don't know. Oh, maybe I'm not seeing the reason. I don't know.
No, I take that back.
Oh, okay. Radius, yes.
How? Oh, this is also radius.
Correct.
No, not useful.
You use alternate angles just now, right?
Yeah.
Can you use it again?
I mean, I know that this is equal this,
Okay, good.
but it's unknown.
Then never mind, just give it, just put a notation. Maybe you can put like double. Okay, can.
Mm. Mm.
What do you call this angle?
Um.
Angle at, where is it?
Circumference.
No. Where is this? What is
Center.
point O? Angle at the center equals to, what's the angle at center equals to 2 times
Circumference. So this
angle
is
at circumference. Huh? Sorry, what?
wait. What's the
You look at the, do you remember the where was that? Was it this guy? Yes, correct. This one. I just bumped a message on the Telegram. Proof in plane geometry.
Okay.
Look at the first one. Angle at center equals 2 times angle at circumference. So how? Turn your head around. BOQ is an angle at center. So what do you think is BOQ now?
BOQ is 1.5x.
1.5. No. This VXQ is in the middle of nowhere. You don't know it. No. Look carefully at the relationship. Usually there's a center, angle at the center, angle at the circumference. So angle at center is 2x, or maybe I'll use a different letter, 2 theta, and that is theta.
Oh, it is.
This guy is
2x.
Yes, correct. There's an angle at circumference, there's an angle at center, right? So if this is x, that will be 2x. Exactly. Good. So we can write that down, 2x. Okay, then can you see the relationship
180 minus 3x. Or actually exterior angle.
Equals to sum of what?
Sum of angle.
No, sum of what?
Sum of
Angles. If this is exterior, what's beside it?
interior.
Interior, but so is it sum of interior? No, what? There's only
But
one
it's
angle
not
there.
including, it's not
So it's sum of interior opposite angles. In other words, this one and this one will give you this one. Okay, maybe I do it like this. Single tick here, double tick here will give you the triple tick here, provided this is a straight line. This one is a straight line. Okay, then it's proven already. Okay, I think it's better if I write it out. Can I understand already, right? The flow of the proof.
Yeah.
So we can say we let angle, what is it? Let's say we start with angle BAQ and we call it X. So in that case, angle BOQ must be, 2 times of angle BAQ. Because angle, can I just let you write it on your own? Angle at center equals to 2 times angle at circumference. So it's 2x, right? Then what else do we know? We also know that angle AQP, this guy here must be the same as that guy there, BAQ. Why? Alternate angles, Z shape, right? Z shape here. So these two angles are equal. Then this is just X. So now we know 2x here and X there. Can we find the last angle? Yes. Angle BXQ equals to the sum of the interior opposite angles, which is the sum of angle BOQ and AQP. This is sum of interior opposite angles equals to exterior angle. This is 2x plus x and it's equal to 3x, which is 3 times of angle What was the question? PQA. PQA. 3 times. Yeah, correct. PQA. Right? Because X is here, which is PQA. Okay?
Mm.
And yeah, then shown. Done. Good. Okay, so this is basically everything you learned from Emacs, but made way more difficult. You see, there's no new concepts being introduced here. You didn't have to use alternate segment theorem, midpoint theorem, or any other things. This one is just a shortcut. Sum of interior opposite. Exterior angle equals sum of interior opposite. You can always take 180 minus 2x minus x, and you get this angle. Then you take 180 minus that one. Do you get what I'm saying? You get what I'm saying? This one,
Yeah.
you can do in 2 steps.
Yeah.
Find this one, it will be 180 minus 2x minus x, which is minus 3x. Then these two angles must add up to 180. 180 minus away 180 minus 3x with brackets. You'll end up with 3x. Okay, good. Question 12 done. Let's move on. Is there any more questions? Let's see. Last one is it? Question 13. Okay, in the figure, O is the. Let me just draw the diagram first. Okay, I'll have to call it a day. This will be the last question. Okay.
All right.
Okay. Yeah. Then homework I will just assign you. Let me go and take a look at the questions first. Okay. Then maybe I'll get you to do another paper, like from our school. Okay, let me just copy the diagram first. Wow, this one. Okay, A goes to B, then to C. All right. Let me mark the center first. Doesn't look good. Okay. Okay, something like this. Then you bring it down. Oh, like this. Okay, good. And then you can link here to here, there to there. What else you want? There to there, there to there. Is there anything else? No, okay, then just label the points. Point A, point O, point D, point Q. A bit off my diagram, not so accurate. Okay, point P. The O, AOQ should be aligned. Okay, let me just tilt it around to make it look nice. Yeah, something like this. Okay, good. Can let's see. In the figure, O is the center of the smaller circle passing through the points A, B, and D. Given that lines A, B, C, and ADP are straight lines, so I'll just highlight it. They are straight lines, and that ODP, C, and B are points on the larger circle, prove that angle ACD equals to 2 times of angle BAD. So you want, I'll just label in, let's say I use pink. This angle here is X. And then this angle here, BAD, I don't know what is it, so I'll call it Y. They're asking you to prove that X plus 2Y equals 180 degrees. Okay? Yeah, so how?
How? How? Okay.
You think of 180 degrees. Look through the rules list of rules you have that's related to 180.
Angle sum of triangle.
Anything else?
I mean, interior angle also at 180.
Anything else?
I mean,
Correct, but there's more.
angle on straight line.
Correct. Anything else?
Um, angles in opposite segment.
That's the one.
Why? Wait.
So you look at the diagram, and angles in opposite segment requires a what shape? What quadrilateral?
Cyclic quad.
Correct. Cyclic meaning it passes all 4 points lie on the circumference. Can you see that? How is it helpful to you here? And you see this one requires a 2y, right? You have a 1y. How do you link from 1y to 2y? Double it. 2 times.
Angle at center equal to 2 angle at circumference.
Exactly. So yeah, so instead of calling that 180 minus x, what's another way to?
It is also equals to y divided by 2.
No, which is the bigger angle?
Y times 2.
No.
2y.
2y. Yes. Angle BOD is 2y. Angle BOD is also 180 minus 2x. Then you're done. Move the x over. Okay. I'll leave you to write it up on your own, okay? Reason. Yeah, this one. Double. Draw double line. Why did I draw double line? Because it's double the angle. So 2y or 180 minus 2x. Okay, good. Part 1 is solved. Let's move on to part 2. Angle ACD is an isosceles triangle. Isosceles triangle, what are the 2 key properties? In terms of the length, the sides are equal, right? Adjacent side. In terms of the angles, here they never give us length, so it's not relevant. They never give us any length.
Yeah.
Isosceles triangle, the other property is
base angle of isosceles triangle.
Base angles of isosceles triangles are equal. Yes. Why is so funny? I don't understand. Right? Base angles are equal. Right? So I think you can tell, right? They are referring to these 2 base angles that are equal, right? The angle y and the angle y here.
Yeah.
So you need to show this is angle y. That's really what they're asking you to do.
Okay.
How?
How? This is 2y. This is, this is not. Okay. How? Is that what's the rule with semi-cyclic quad?
What's a semi-cyclic?
What is it called? The one where like there's one at the center, then the rest are at the
angle at wait. Angles in same segment or what? Angle at center is 2 times angle at circumference. Like this?
That's the only rule, is it?
Yes, I guess so, yeah. If it involves a center, the rocket ship one. Or the duck beak. Can you see the duck?
How do I prove this is why? Okay, this is the same radius.
How about I see y and x, right? A bit complicated. Why don't we keep everything in terms of x? So in other words, let me just take a screenshot of this and then I'll paste it at the side, so that you can write up the proof for part 1 on your own later. You can zoom in. I think it should be clear enough. I'll just change everything in terms of x. Okay, everything rewrite it in terms of x. So can you tell me what's y in terms of x? In other words, Make y
y
the subject.
equals to 180 minus x divided by 2.
Simplify a bit, you get 90 degrees minus x over 2. Is that okay?
Yeah.
Can so I'll just change it into 90 degrees minus x over 2. Wow, that was a bad choice. Maybe I shouldn't have caught this x. If not, I have to deal with a divide by 2.
180 minus x minus 90 plus x over 2 equals to this, which will be y. Or 90 minus x over 2.
Yes, correct. This is our triangle, so you just need to take angle sum of triangle 180 minus those two. Okay, this one I'll just write it down. Angle ADC equals to 180 minus angle DAC minus angle, what is it? ACD. This is angle sum of triangle. So this is 180 degrees, you minus away bracket 90 degrees minus x over 2, minus away x, right? Simplify a bit, you get 180 degrees minus 90 degrees plus x over 2 minus x. 180 minus 90 is just 90. Half of x minus away 1 of x means you're left with just minus half of x, which is actually just 90 degrees minus x over 2, which is actually just y. Okay, good. So therefore, actually you don't need y. You just need to show that these two are equal, right? Where y is the, what is it, angle BAD, right? Angle BAD. So therefore, we have shown that angle BAD equals angle ADC equals to 90 degrees minus x over 2 equals to y, which implies that by the base angles of isosceles triangles, base angles of isosceles triangles, what is it? Sorry, what is it? What are we trying to prove? Triangle ACD, right, is isosceles triangle. Okay, good. Now finally for part 3, PQC plus 3 times BAD equals to 360 degrees. Let me just label the diagram first. PQC, so I need this angle here. What else? We need 3 times of BAD. 3 times of that guy. Okay, fine. Since we already got 90 degrees minus x over 2, we got 3 times in front. Let's just calculate it first. Right or not? If you don't know anything yet, just calculate it. What's 3 times BAD? So it's 3 times of 90 degrees minus x over 2, which is 270 degrees minus 3 over 2x. Wow, that's not looking very nice, but okay. Then what's PQC? It's just something, I don't know. But we know that PQC plus 3 times of BAD, you want it to be equal to, so it's 1 to be 360 degrees. This one like trigo proof, right? You start with the conclusion, then you just try to manipulate it so it looks like a simpler format. So I'll just copy down this. Okay, sorry, this one I should draw a line like this. This one is, okay, part 1 is DIY, do it yourself. Part 2 is these two parts. Then now is part 3. Let me just paste the, wow, I need the diagram. Okay. I hope you still remember the BAD is 90 degrees minus x over 2, and I already calculated this before. So I'll just paste it over here. Then I will replace it with PQC plus 270 minus 3 over 2x equals 360 degrees. We have yet to prove anything. All that we have done is to work on the left-hand side, sort of. Work on the left-hand side. So this is what we want. Can you see what we want? So what does it mean? It means that in order for the left-hand side, what we want is for the left-hand side to be equal to the right-hand side, right? Yes. Okay.
Yeah.
So we are not trying to solve for x. We're just trying to show that it's equal. We don't need to solve for x. We don't need to solve for x. We cannot solve for x. What we do realize is that, or hopefully you can realize, is that PQC, wouldn't it be nice if it was positive 3 over 2x? Where did I get this from? Sorry. Positive 3 over 2x plus 90 degrees. Can you see why that would be a good idea? You're just making angle PQC the subject.
Okay.
This 2 will cancel. 270 plus 90 gives you 360. Okay, so our goal now changes to the following. Instead of wanting to get this guy, instead what we want is to show that angle PQC is this guy, which is really just 90 degrees plus 3 over 2x. I skipped a few steps. Is that okay?
Mm-hmm.
Okay, so now our goal changes. PQC show that it's equal to 90 degrees plus 3 over 2x. That's the real question. Once we've shown this, we can just substitute in here, substitute in the 90 minus x over 2 there, and then it will be equal to 360, and then we're done. So how do we show it's 90 plus 3 over 2x? Our goal, let me write down the goal. Our updated goal is to show that angle PQC equals to 90 degrees plus 3 over 2x. Paste it here. Our objective. How?
Mm-hmm. Is this plus 2x?
Plus 2. Oh, yeah.
But I don't, that's not helpful.
Oh, there's a question 14.
Oh,
Let me see again. Okay. Exterior angle equals to sum of interior opposite. Let me just show you this part. This guy here that we're trying to find, right? This PQC is equals to the sum of these two guys. Can you see? Maybe I use a different color. Maybe this weird color, light blue. I don't know what color. Okay, do you agree? This PQC is the sum of these two angles? Yes? No? Yes?
mm-hmm.
Exterior angle equals to sum of interior opposite. Okay, good. Then how?
Then how?
What do you think is this angle? BPD.
BP.
BPD. This one. BPD. BPD is what a part of what shape? Triangle BPD. Then you need to join an extra line. Not so good, not such a good idea. What shape is it a part of?
Triangle.
Oh no. Don't look at triangles. Look for a four-sided figure.
It's part
of BPD is part of BPD.
What this thing?
BPD. Is that? Wait, sorry. Can you draw that again? BPDO, right? This shape here, cyclic quadrilateral. Then angles in what segment? Same segment?
Opposite segment. So
Opposite
then this
segment.
will be 2x.
Exactly, very good. If there's 180 minus 2x, so opposite it must be a 2x. Very good. Almost there. Almost there. You said just now, right?
This is
2x,
x.
right? X. Why?
No,
You see
no.
Z shape, is this a Z shape?
No,
No,
not
must be
parallel.
parallel. So you see 2x, just now you told me minus x over 2 plus 2x will give you 3 over 2x, right? So you're almost
Yeah.
there.
This plus this give you this.
Sorry, which and which?
Angle BAD
Why
plus
BAD? How do you know?
EQ.
No, we only know it's CDP. How do you know it's the same as this guy?
How you know?
Yeah, how do you know that? I'm asking you. You don't know that, right? So what do we know? We know that let me just use a different color now. Let's say this angle beside it. If we know that angle ADC, right, we can just take 180 minus and then we'll get our answer there. Right? Our current question mark is this fellow here, question mark.
180 minus 90 minus x over 2 minus x gives you ADC, angle sum of triangle. Then you take 180
yes,
minus whatever you got there.
Actually, you already
Then,
know what's ADC. Look carefully. Remember part 1? What triangle is this?
but actually, don't need it. You just use this plus this, then you get this.
Actually, yeah, true. Oh, I didn't see that. Yes, can. Wow, that's faster. Yes, correct. Exterior angle equals sum of interior opposite. Sorry, I didn't see that. Yeah, correct. And then you're done. I think so. Let's work it out. I'm not sure. I'll just work it out inside the circle. So we have what? Part 3. Angles. Let me see. Angle CDP. This angle here is equals to sum of interior opposite angles. CDP is the exterior. So we can just take the angle DCA. We add on to angle DAC. Right? Sum of, I don't write the reason, is that okay? Exterior angle equals sum of interior opposite angle. You'll fill it in on your own now. Then DCA is a x, DAC is a 90 degrees minus x over 2. Clean up a bit, we get 90 degrees. Plus 1 minus half is a plus half. So positive x over 2. Okay? Can? Good? Good. Box it up. 90 degrees plus x over 2 is the first angle. Then we still need the 2x here. Why is it 2x again? Why is it 2x again? This one?
It is 2x because angles in opposite set.
Okay. I'll call this angle DPQ. So angle DP, D and P look the same. DPQ equals to angle DPB. Right? Just extend from Q towards B. This is really just, what happened? Okay, I don't know. Yes, angles in opposite segment. So this is equals to 180 degrees minus away 180 degree minus 2x. Angles in opposite segment. Simplify minus 180 then plus 2x. You're left with a 2x. Okay, good. Let me box it up. The second angle we found. Okay, and finally we get our angle PQC to be what? Angle PQC must be, can I just write it down as 90 degrees plus x over 2 plus 2x? I don't write the actual name. It's CDP plus DPQ. I just substitute directly. Is that okay? I hope you're not confused. Can? Maybe I'll box it up just to remind you. Box this. Maybe I'll put a double box here. Double box. Then you'll know for sure what I'm referring to. Single box and double box. Right? Simplify, calculate it. Half of x plus 2x is, let me use a calculator. 1/2 plus 2. 5 over 2. Okay. 90 degrees plus 5 over 2x. Did I calculate something wrongly? Something is wrong. Let me see. I got tricked. Hey, why 2x? This should be just minus x. Right? It's x. Angles in opposite segment just minus 1x. How come got 2x? Eh? I'm not sure. Okay, let me see if they're working again. Yeah, no, it's just a single x, right? Yeah, okay. Like this. And then 3 over 2x. Right? Can? Can? Yeah, I made a correction here, and here, and here, and here. Where else? I hope there's nothing wrong. Okay, good. And then we have shown angle PQC to be 90 degrees plus 3 over 2x. Are we done? No, we still need to go on to fill in the blank. Okay, I'll just copy down this conclusion we have here, and then I'll paste it over here. I'll just paste it over here. And then I'll say proven above. Then all you need to do is to link it back to here, then you work backwards, and then you jump back to 360 degrees. I'll leave that to you. Is that okay? Can? Yeah, and then you're done. Easy? Can. Okay. Can. Then your homework I will assign later, and that will be all for today. I will just charge you 1 hour. Can?
Actually, I think it's like 1.5 hours.
Oh, yeah, actually.
If you want, like.
If it's half hour, then I should extend. Should I go through one more question?
No, as in, isn't it already like 1.5 hour? Because you start at like 9:10.
Oh, okay.
Then now it's like 10:40. So it can be 1 hour 30 minutes.
Oh, okay. Can I will charge that. All right. Thank you.
Yeah.
Ken,
okay.
That'll be all for today. I'll send you your homework later.
Thanks.
Thank you. Ken, bye-bye.